Hi, welcome to Juno Bot Build Part 3. Today we're going to talk about coding our Juno Bot. In this project, we'll use MBlock, a block programming software platform. We'll go to www.mblock.cc to download the software. Once you get to the MBlock webpage, go to Downloads and download the software that you want to use, either the web version or the desktop version. For this project, we'll be using the desktop version for Mac. Once you've downloaded the software, launch the software. First, we'll need to add our device. We are using an Arduino Uno for this project. Click on Add, and you'll see the device that you'll need to add. Find Arduino Uno and click on it, and click OK. You'll see the blocks appear. All these blocks correspond to some function on the Arduino. We'll start with the events. We'll use one event block first, then go to Control, add a wait block, which is the same as the delay on the Arduino. We'll add 2 seconds. Next, open the pin blocks. Find a set digital pin block and add 2 set digital pin blocks. We're going to be coding the LED lights. Our LED lights are set in pin number 12 and pin number 13. We will set our pins to high. High indicates that the electricity will be on in those pins. Next, we'll go to the event blocks. We'll create another event. Then we're going to go to the control block and add another wait block. Then we'll go to the pin blocks and find the set servo pin blocks. We'll select 2 servo pin blocks that will correspond to our 2 servo motors. Our servo motors are set on pins 5 and 6. And then we'll set those to 5 and 6. In order to set the direction for forward, we're going to change our angle to 120 and 60. 120 and 60 indicates they will be going in the direction forward. Next, we're going to get another wait block. In this case, the wait block will indicate duration. We'll set it for 2 seconds. That will indicate that our motors will turn for 2 seconds. But we need to turn those motors off once those 2 seconds are up. We're going to select 2 set servo pin blocks. We'll make sure our servo pins are set to 5 and 6. And now we'll need to set our angles to 90. In a continuous rotation servo, 90 will bring the servos to stop. 90 indicates stop. Now we're going to duplicate this set again by right-clicking and selecting Duplicate. We'll drag a duplicate set of functions over. Making sure that our servos are at 5 and 6. We're going to change our angles to 60 and 60. This will turn our servos, or our whole robot, to left. We're going to change that duration to 0.8 to shorten up the turn. We'll leave our stops at 90. 60-60 indicates a left turn. 90 again indicates stop. Let's duplicate that function again and put it below. Now we're going to code for a right turn. Again, we need to make sure that our servos are set at 5 and 6. And now a right turn will be set at 120 and 120. and our duration of the turn will be set at 0.8. Also, we'll include the stop at the end, indicating our angle at 90 and 90. Next, we'll create another function block by duplicating a previous one. Make sure our servos are set at 5 and 6. This time we'll be coding the robot to move backwards. Previously, a forward was 120 and 60. To go backwards, we do the opposite. We'll code one servo at the top to be 60 and the one below at 120. We'll make sure the duration of that is 2 seconds. Our stops will be at 90 and 90. Finally, we'll go back to the event block and start another function. We'll go back to the pin blocks. We'll find a set digital pin block. We'll get 2 of those. This time we're going to make sure our lights turn off at the end. So here we'll set the digital pins again to 12 and 13. Those are the pins that our LEDs are set to. And we'll change it from high to low on both. At this point, we're done with our sample demo program using block coding. Save your work and then stay tuned for the next portion where we upload the code to your Juno Bot. The next step after we code, now it's uploading our code to our Juno Bot. First, we're going to need to connect our USB cord to the USB port on our Juno Bot. Now it's time to connect your device and upload your code. Once you've connected your device through your USB cord and your USB sockets, find the Connect button on M-Block. Click on Connect and then check the box that says Show all connected devices. Find the device that has USB modem in it, then click Connect. Once you're connected, the lights on your device will flash. Make sure you're on upload mode and click the upload button. You know you're successful if it completes in green. If your upload was successful, your robot should be working. Now you can take some time to tweak and modify your code. In this next part, we'll learn to code our Arduino Uno and our robot using the Arduino Uno platform. Go to arduino.cc and download the Arduino software for your desktop computer. Once you get to the website, go to Software and Downloads. Find the software that you want to download for your desktop. Once you've downloaded the Arduino software, launch the Integrated Development Environment software to start coding in Arduino C language. Arduino C is a simplified version of the C++ computer language. Once opened, maximize that window and erase the code that is appearing. We're going to have a clean slate so we can start fresh. You'll need to prepare your Arduino Uno so it can communicate with the software. Go to Tools at the top and select Board. In that section, you want to select the Arduino Uno board. Now we're going to begin adding code. We're going to start by adding a library. A library is a function that allows other peripherals to be attached. In this case, we'll add the servo library. So type the servo library as shown. Next, we're going to add some servo information and name our servos. We're going to name them myservo1 and myservo2. Be sure that you always include the semicolons at the end of each function that you type in. Next, we're going to add the setup portion of an Arduino program. In the setup section, you include information that tells the Arduino what to do with certain pins. Copy the code as shown for the setup portion of this program. We'll start with the delay function. This will give us some time before other portions start to initiate. We'll start with a delay of 5,000. 5,000 indicates 5,000 milliseconds, which is equal to 5 seconds. Now we're going to indicate the pin mode for pin 12. We're going to call that an output. Since we're also using pin 13, we'll also call that an output. Pin 12 and 13 are the pins that belong to our LED lights. We are telling our Arduino Uno we will be using pins 12 and 13 as outputs. Next, we'll be using the digital write function. The digital write function, in this case, for pins 12 and 13, will be set to high. High will indicate that pins 12 and 13 will be on. In other words, electricity will be on and flowing through pins 12 and 13. Pins 12 and 13 are pins that belong to our LED lights. We'll give ourselves some space, and now we'll identify our servos with the attach function. Our servos, in this case for our motors or our wheels, will be using pins 5 and 6. So we'll use our names myservo1 dot attach and myservo2 dot attach with the number of the pin that they will be attached to. Next, we'll be adding the void loop section. The void loop section is where we will place all the functions in code that we want to loop or run continuously. So we start with void loop, our parentheses, and our bracket. We give ourselves some room. And now we're going to indicate our first function that will give an action to our robot. We'll indicate which servo we want. In this case, we want both wheels to move forward, so we'll use the function myservo1.right and the angle that we want it to move, or the direction. In this case, 60. And the other wheel will move with the angle that indicates 120. So myservo1.right 60, myservo2.right 120. This will move the robot forward. The next step will be to actually add a delay. In this case, delay will indicate the duration of the movement. So in this case, we're going to say delay 3000 or 3,000ths of a second, which equals 3 seconds. Then we're going to stop our wheels for a pause, and we'll add the function myServo1 write 90 and myServo2 dot write 90. When servos that are continuous rotation servos are set to 90, in other words, it will be at 0 or at a stop. Next, we'll add our delay to indicate the duration our motor will be stopped. We'll use a 1 second delay, so we'll type in 1000. Next, we'll start our turns. We'll use the same function, myServo1 dot write, and we'll use the angle 120, and we'll indicate a note to ourselves, left, and myServo2 dot write 120. That will turn our wheels so that our robot turns left. We'll add our delay, and we'll use 800 or 800ths of a second. Now to stop our motors for a pause, myServo1 write 90 and myServo2 dot write 90. We'll add our delay. We'll use 1 second delay by typing in 1000. Next, we'll give ourselves some space and begin our right turn. Using the same function, myServo1 dot write, we'll change the angle to 60. Always remember to complete each function with a semicolon. We'll add our note using the backslashes. Then add myServo2 dot write and 60. This will turn our robot to the direction right. We'll add our delay using an 800th of a second delay. And then we'll bring our motors to a stop by typing in myServo1 dot write 90 and myServo2 dot write 90, and our delay of 1 second or 1000th of a second. And finally, our last group of code will be to have our motors run backwards. Same function, myServo1 dot write, and this time we'll use the opposite of what we did in the forward function. We'll start with 120 and myServo2 dot write 60. We'll add our delay, and here we'll have our motors run for 3 seconds, so we'll use 3000 or 3,000th of a second. And then we'll add our final stop to our motors, myServo1 dot write 90 and myServo2 dot write 90, and we'll give it a delay of 1 second. And then finally we'll clean it up and make sure that there's a final bracket at the end. You'll notice we coded our very first forward motion, our stops, our left motion, another stop, a right motion, a stop, a backwards motion, and a final stop. And it's all in the void loop section, which will repeat. Next, we'll need to verify or check to see if our code is correct. By clicking on the check mark, your mistakes will be highlighted in pink. Check any mistakes and make your corrections. Finally, connect your robot via the USB port. Then, on the software, go to Tools, make sure your port is connected, select your port, then go up to the arrow button to upload your code. Click on the arrow and it will begin to upload your code. Now your robot should work.